Alright everyone, welcome back to the channel. Today we're diving into some super important topics for building robust and maintainable applications. We're going to start by talking about centralized logging. Understanding what's happening inside your application is crucial when things go wrong. And right alongside logging, another critical practice is automated testing. Making sure your code is doing exactly what we expect it to allows us to build with confidence and refactor fearlessly. So in this video, we're going to cover both. We'll look at setting up our logging solution, and then we'll move on to implementing our tests. Think of logging like keeping a diary for your software. As your application runs, it writes down important events, what's happening, who's doing what, and especially when things go wrong. This diary is absolutely essential for understanding how your app is behaving in the real world, diagnosing problems, and figuring out why something broke. But in a complex application like the one we've been building, with different layers like our data access services, web API, and even client apps like Blazor, and eventually Maui, having separate diaries everywhere gets messy fast. That's where centralized logging comes in. We want all those important notes from every part of our system going to one place. For this, we're using a fantastic logging library called Serilog. Serilog is powerful because it does structured logging. Instead of just writing plain text lines, it captures information as organized data, like key-value pairs. This makes searching, filtering, and analyzing your logs way easier later on. And where are we sending these structured logs? Right into our database. Saving logs to a database gives us a persistent, searchable, and queryable history of everything that happens in our application. Now, how do we make sure logs from different parts of our API get enriched with useful context, like who the user is? That's where middleware comes into play. We've implemented a custom piece of middleware that runs early in the API's processing pipeline. Its job is to look at the incoming request, see if a user is authenticated, grab details like their email and ID, and then attach that information to the logging context for that specific request. So any log written during that request automatically includes those user details. Pretty neat, right? One of the biggest benefits of centralized logging is how it helps us deal with exceptions. In a layered application, when an error happens deep down, maybe in the data access layer, it often bubbles up through the service layer, then the API layer. With our centralized logging setup, we don't need try-catch blocks everywhere just to log an error. We let those exceptions bubble up, and our centralized exception handling middleware at the API level catches them. This middleware is configured to use our Serilog logger, so the exception details, including the stack trace and all the rich context we've added, like the user info from our middleware, get automatically logged to the database. So when do we still use try-catch? We use try-catch when we can actually do something about the exception at that specific point in the code. Maybe we need to clean up resources, try an alternative operation, or translate a low-level error into a more business-meaningful one. If we catch an exception just to log it and then rethrow it, that's often a sign that centralized handling is a better fit. Finally, what about our client applications, like our Blazor front-end and the Maui app we'll build later? We definitely want their logs too. But we don't want them talking directly to our database. Instead, these client apps will use a Serilog sync, or a similar logging mechanism, configured to send their log events over HTTP to a dedicated logging endpoint that we've created in our API project. The API endpoint receives these client logs and then uses the same centralized Serilog setup to save them to the database. This keeps our database secure and all our logs in one place. For the testing part, the first step is to set up our testing environment. The best practice in .NET is to keep your tests separate from your main application code. It keeps things clean and organized. So we're going to create a brand new project in our solution, specifically for our tests. For now, we'll focus our initial testing efforts on the service layer of our application. This is where our core business logic lives, and testing this layer thoroughly gives us a lot of confidence in the application's behavior. When we create our test project and start writing tests, we'll also pay close attention to naming conventions. Having clear and consistent names for our test project, folders, and test classes is really important for making our tests easy to understand and navigate later on. And here's where things get interesting. We're going to be using GitHub Copilot right inside Visual Studio to help us write these tests faster and more efficiently. You'll see how this AI assistant can suggest test cases and code snippets, making the testing process smoother. So that's the plan. We're building a robust logging system using Serilog, saving to a database, leveraging middleware for context, and handling exceptions centrally. Then we set up our test project, figure out the best way to structure it, and finally start writing some unit tests for our service layer, all with the effective help from Copilot. Let's jump into the code and see how it all comes together. Well, our work here is going to start with the API project. In this first part, we want to get all the prerequisites ready for logging in this project, like installing the Serilog packages. Okay, so right here, I'm just searching for Serilog, and I'm going to choose Serilog ASP.NET Core. Since we're planning on storing all our logs in the database, I'm also going to pick Serilog Syncs MS SQL Server. Now, as you can see, we've got 6 packages here that need updating. It's super important to us to keep the packages we're using across our entire solution updated. It just helps keep everything humming along nicely. I'm going to do the same for our other projects too, because, they're all related and gotta be on the same page version-wise. Okay, now I'm going to add the Serilog log settings to appsettings.json file. Alright, the first part of our configuration is the root Serilog section. This is where all the magic begins. This tells .NET Core that we're using Serilog for structured logging. The using section is helpful when dealing with multiple syncs. Here, we're saying, hey Serilog, we want to use the MS SQL Server sync. This sync allows us to write logs directly to a SQL Server database. In the using section, we could also add other syncs like console to see the logs right there in the console while we're developing, or file to save logs to a file on the server. But for right now, we're going to stick with just SQL. Now we define logging levels. Defaulted information means that logs with information level and higher will be captured. The override section lets us fine-tune logging for specific namespaces. Microsoft and system logs will only show warnings and above to reduce noise. For our app namespace crm.api, we're going to keep it at warning for now, just to capture logs at warning level and higher. Later on in this episode, we're actually going to test what happens if we change it to information. This is where we tell Serilog where to send the logs. So here we specify the MS SQL Server sync. We're going to use a named connection string that's defined right at the top of this config file under the connection strings section. Then we get into sync options section. Table name tells Serilog to write logs into a table called logger. Schema name is the SQL schema. In most cases, it's just DBO. Auto create SQL table to true. Means Serilog will automatically create the table if it doesn't exist. Batch posting limit is how many log entries to write at once. Here, it's 50. Batch period is basically the time between batches. So right now, it's going to wait up to 15 seconds before actually writing those logs. We can definitely change that in the future for our production environment. This batching improves performance by reducing the number of database writes. Next, we configure which columns are included in the logs. We add the log event column to store raw event data. And we remove message template in properties if we don't need them in the table. Now we define custom columns for additional context. User email, to capture which user was logged in. User IP, useful for tracking the client's IP address. Request path shows which endpoint was hit. Status code, the HTTP response code, elapsed, how long the request took, in milliseconds. Each of these helps build a richer picture of what's happening in our app. We're going to fill in these values using custom Serilog enrichers in the code a bit later. And that's it. This configuration is setting up our logging with Serilog to SQL Server. Okay, let's move on to the next step. Now we need to activate Serilog in our application. And for that, we're going to use our program.cs file. First line tells the app, hey, use Serilog as the logging provider for this application instead of the default Microsoft one. This is what hooks Serilog into the .NET hosting pipeline. Then here, it tells Serilog to read its configuration from our app settings.json file, the exact file we just configured earlier with all the syncs, levels, and options. So instead of hard coding anything in C#, we keep everything clean and centralized in our config file. Next up, enrich from log context enables Serilog to automatically enrich every log entry with extra context. For example, if somewhere in the code we add this, then that user email property will be included with all logs created during that request. This is super useful when we want to track extra details like user info, IP addresses, request IDs, or anything else, especially helpful when debugging issues in production. Now that we've wired up Serilog in the database sync, let's add something really powerful. A custom middleware that logs detailed information about each request. First, I create a new folder for our middleware. Why do we even need a logging middleware? Well, imagine running a live application. Our users are clicking, logging in, making API requests, and suddenly, something goes wrong. How do we figure out what happened, who caused it, or how long the request took? That's where our custom logging middleware comes in. Instead of sprinkling logging everywhere manually, this middleware gives us one central place to capture important request details. In .NET, middleware is like a pipeline that handles each HTTP request and response. Every request flows through a series of middleware components, like a chain. Each one can read, change, or pass the request to the next. And finally, it reaches our controller or endpoint. Alright, I'm going to inject three things directly into the class. First, this is going to represent the next middleware in our pipeline. Then, we've got the logger that we'll use to write all our logs. And finally, our token service, which is going to extract the user's email from a JWT token. So right here, I'm just going to accept what Copilot suggested, and then adjust it a little bit. Like all middlewares, this has an invoke-async method that runs for every HTTP request. Right at the start, we try to get the endpoint from the request. If there's no endpoint, we just skip logging and call the next middleware. Here I declare variables for user email and user IP. Then I grab the authorization header. If the token starts with bearer, we extract the JWT token. Copilot suggested getting the user email from the principal, but I actually have a better idea. Instead of that, I'd like to add a new method for getting the user email in our token handler. Let's do that. First, let's just remove this. I'm going to add the method signature in the interface now. And here's our method for getting the email from the token. It's going to use JWT Security Token Handler to read and decode the token. Then, it looks through the token's claims, which are basically just pieces of data inside the token, and it finds the one where the claim type is email. Finally, it returns that email value as a string. So, let's head back to our middleware and use this one. Okay, here it is. Next up, I'm going to create a stopwatch to measure how long this request takes. Then, I'm going to start a try block to handle our logging and any possible errors that might pop up. Right here, with these using statements, we're going to enrich our log context with our custom properties. This way, Serilog can store them in the database, just like we defined in our app-settings.json file. Now, I'm going to add a condition to check if the response status is less than 400, or equal to, or above 400. This helps us quickly tell if the response was successful or not. You'll see Copilot actually suggests a different approach, checking if the method is get or not. So this is a great spot where you can totally customize your logging logic based on exactly what you want to capture. Then, outside of this if statement, I'm going to prepare the log message. Now, everything here is ready. For the if section, we're going to log as information, and for the else, as error. Okay, perfect. Here, let me just paste the code for our catch section. If anything goes wrong while processing the request, this catch block is going to kick in. We're going to stop the stopwatch, enrich the context again, and then log the exception. Right here, we're checking whether the HTTP response has already started being sent to the client. This is a super important safety check to avoid trying to modify a response that's already on its way out the door. Think of it like this. Let's say you're sending a physical letter to someone. If the letter hasn't been mailed yet, you can still edit it, add a note, or even replace the envelope. But once it's already in the mailbox, too late. You can't pull it back or change what's inside. That's exactly what context response has started, checks in our code. So, if the response has not started, then we clear it and prepare our response model and write to it. This makes sure the client gets a nice, clean error message. By using JSON naming policy camel case, we're returning a clean, front-end friendly JSON response, just the way the client expects it, and it really helps us to easily deserialize it on their end. And no, we don't need a finally block for this try catch here. Finally, we create a handy extension method. This way, we can call our logging middleware in program.cs and plug it right into the request pipeline. I'm going to add our logging middleware right before authorization. And that wraps up this section. Our logging middleware is ready to go. We'll test it out a bit later. Now, to test what we've done so far, I want to throw an exception on purpose. This way, we can see how an exception that occurs in the service layer is handled in our middleware and API. To do this, I'm going to go to the user controller and comment the user ID here. If you remember, in the service layer, if the user ID is empty, an exception is going to occur. Before I run the program, let me show you the database so you can see that the logger table hasn't been created yet. We set in our settings that if the table doesn't exist, it will automatically create it. Well, as you can see here, after running the program, the logger table was created, which of course is empty now. So let's log in to call the getUserProfile method. Well, as is indicated here, an exception occurred in the service layer, stating that the user ID was empty. If I continue the program, I'm redirected to the login page again, and I can also see the appropriate error at the bottom of the page. This shows that the front end was able to receive the appropriate response model, process it, and finally display it to the user. Of course, as I mentioned before, when an error happens, we avoid showing detailed messages to the user. A lot of the time, we just display a general message, and that's to keep our application secure. But now, from this point on, errors will be fully saved in our database, so developers and troubleshooters can quickly find and fix issues. So now, if we go back to the database and run this query, a record has been added to the table. It seems that Serilog and the middleware are doing their job correctly. Here we've got both the user's email and their IP address. Just a quick heads up, this value is the IP version 6 loopback address. It represents the local host. We are running the application locally, and the web server like Kestrel, IIS Express, etc., is resolving the client's IP address using IP version 6 by default. In production, it's going to save the user's actual, correct IP address. Okay, very good. The email, IP, and request path are filled in. The status code is empty, and the processing time was very fast. That is why the elapsed column is 0. Now let's check the event log column together. As you can see, we have an exception here, and this shows that we entered the catch section in the middleware log after the error occurred. I suggest that you set a breakpoint in the catch section while working with this source code. This allows us to debug any unwanted errors that occur during development and quickly find out about them. I think we are storing good information when an error occurs, and this helps us to fix the problem as quickly as possible. For example, here it is saying that the user ID cannot be empty, and also where and for whom this problem occurred. Okay, let's go back to the code. I want to show you another way we store logs, but first, let me fix this user ID. Here I want to change the minimum level for the API to information. Alright, let's test the program again and check the results together. Okay, great. It looks like the user is already logged in. We can open the user profile page. This page loaded completely without any problems or errors. Let's take a look at the logger table again and see what has changed. Well, apparently another record of the information type has been added. But I expected more. If I run the select command again, you will see that it has added other records to the table. This is because of the settings we made. We set it up so that the logs are not stored individually in the database, but are stored in the database based on the time period or their number. This helps reduce the number of requests to the database and has a positive result for our performance. Well, here it shows that before the user's profile page even popped up, it requested a refresh token. And that's because we've set our refresh token expiration to a pretty low value. Another exception that does not exist, and the exception fields are empty. Okay, here everything looks fine. Let's go back to the code and next step. So far we've learned how to automatically save logs to the database using Serilog, which is super cool. Now the question comes up, what should we do if we want to generate a log manually during the code execution process? This is actually super simple. I'm going to show you with an example. To do this, we're going to go to the refresh token method. First, in order to call the logger, we need to inject it into the class. The way to inject it is like this: iLogger of authentication service, using angle brackets. That's it. Now we can use the logger to write logs anywhere in this class. For injecting iLogger to other classes, you need to put the name of that class between angle brackets. Here, we're using iLogger, which is part of .NET's built-in logging system. But since we've already configured Serilog in our project, all of these log calls are automatically handled by Serilog behind the scenes. So even though the code uses .NET's logging interface, Serilog is the one writing the logs to the database. Okay, let me find the right place in the code. Yes, here in the previous episode we added a try catch. Now, to force it to go to the catch block, we can throw an exception in the try statement, and by calling the logger in the catch section we can generate our error log. This way, we can see the behavior of our code when an exception happens. I just wanted to demonstrate how it works. You can test and debug it on your own. But actually, here we don't need a try catch, because as of now we have centralized logging, and if this exception happens, we can get it by the middleware. I'm going to comment this line out, and I want you to test and debug it so you can get a good insight into how it works. Our source code is going to get bigger and bigger, and it's super important to know how the layers and projects work together. So I'm going to add a to-do here for you. So far, we've been able to manage the errors and concepts that occur in our API or its dependent services. But now the question comes up: what's our plan for the front end? As a software design choice, we don't intend for the front end to access the database directly. The front end only communicates with the core software through API endpoints. To save the logs from the front end, we're going to do the same thing. Serilog, as well as being able to store data in a database, also has the ability to send it to an endpoint via an HTTP call. So for this, I'm going to make a new controller. I'm creating the controller in the public folder because errors might occur even when the user isn't logged in. So here we have an API endpoint called receiveLog. It's a simple HTTP post method that takes a list of logs. Let's create the log model class in the models project. First, I'm going to delete this controllers folder because we don't need it anymore. Next, I'll change the home page so that it no longer needs the public controller. I'm using this model called log model to send a list of logs from the Blazor frontend to our API method. At T is the timestamp, at MT is the message template, and at L is the log level. Now you might be wondering why these property names look a bit unusual. These are actually recognized property names by Serilog. That's why I've used them. So the structure matches Serilog's log format perfectly. I've also added a user email field. Later, I plan to enrich it with the user's email before sending a log to the API. In the future, we will add more to this class, like tenant ID. Now, here in this receiveLog method, for each log in the list, we first try to figure out the log level, like info, warning, error, etc. If we can parse it successfully, we use it. Otherwise, we default to information. We also grab the log message and any exception info that comes along. Then here's the cool part. We push the user email into the log context, so it shows up in the database alongside the log entry. After that, we use a simple switch to log the message based on the level, log information, log warning, log error, and so on. Finally, we return an OK response. Super clean and super handy when you're sending logs from the front end. Alright, in this section, we're going to focus on the front end. Now, before I started recording this episode, I added a few changes to our Blazor project, like some packages that Serilog needs. Well, as you can see in the list, I installed these 5 packages from Serilog. The first one is Serilog.ASP.NET Core, which we also had in our API project. This is going to connect Serilog with the ASP.NET Core logging system, so we can use Serilog throughout our app, just like we implemented and checked out in the previous section. Second one adds a compact JSON-friendly format for our logs, great for saving space and making logs easier to parse. Settings configuration lets us configure Serilog directly from our app-settings.json file instead of writing C# code. Serilog syncs console sends our logs to the console, super helpful during development and debugging. Syncs HTTP allows us to send logs over HTTP to our endpoint. In the API project, we had SQL Server instead of this. These are all the packages we need for our logging system here in the Blazor app. The next thing I did was add some settings to this file. In the using section here we have HTTP and console. This means that logs are going to be sent to an HTTP address and also to the console. Once we place the project in production, we can remove the console one. We've already covered the minimum levels, so let's move on to the write to section. First, we have durable HTTP using file size rolled buffers. What's this funny looking name all about? This is a reliable Serilog sync that sends logs to a remote HTTP endpoint. But here's the cool part. Instead of sending logs immediately one by one, it stores them temporarily in local buffer files. Then it sends them in batches to the server based on time or size limits. It is useful because if your app loses internet or the server is down, your logs won't be lost. They stay safe in those buffer files and get sent later when possible. It's great for front-end apps like Blazor, where internet isn't always perfect. So yeah, durable, safe, and efficient logging over HTTP. Request URI is the address of our endpoint. We use a compact JSON formatter to keep logs clean and lightweight. We store logs in a buffer file in the log folder and send them in batches, up to 50 logs every 15 seconds. This makes it efficient and reliable, even if the network is a bit slow. Then we have the console sync. This just prints logs to the terminal with a nice custom template showing timestamp, level, message, and any exceptions. Super handy for development, and that's it. All the logging settings are centralized in one place and can even be updated in production. Next up is the program.cs file. Here we've also got use Serilog set up for logging. It reads all the Serilog settings directly from our app-settings.json file. And this part, enrich with new logs enricher, is where we plug in a custom class we created called logs enricher. This lets us automatically attach extra info to every log, like a user email, tenant ID, or anything else we need. Alright, let's go check out the logs enricher class now. This is our custom enricher class. It implements the iLog event enricher interface from Serilog, which means it can add extra information to every log. We've got a static property called current user email. If this has a value, we use it to create a new log property called user email and attach it to the log event. So now, whenever a log is written, it can automatically include the current user's email. Super helpful for tracking who did what. Now, you might be wondering, how does this current user email actually get its value? Well, it's not automatic. We need to set it manually. For example, after a user logs in, refreshes their token, or when they first open the website. From that moment on, any log written during that request will include the user's email automatically. I also did one more thing in the program.cs file. Let me show you. I wrapped the whole thing in a try-catch block. The try is where we run the app as usual. The catch catches any unexpected exception that might crash the app, and we use log fatal to log that critical error using Serilog. This helps us understand why the app suddenly stopped. The finally block runs no matter what, even if there's an error, and log close and flush. Make sure that all pending logs are written out properly before the app shuts down. So it's a clean and reliable way to handle fatal errors and make sure nothing gets lost in the logs. So now I'm going to do a little test to show you how to save a log from the front end. Well, I added this line here to send an error. We'll remove it later. I've changed the home page to make it look nicer. Okay, the log is saved in the database, which shows that the Serilog settings are working correctly. But the user email is unknown, which we will fix in the next step. We can also see the log in the console, which can greatly speed up development when we need to create and view a log. As you can see right here, the logs folder has also been added according to the settings we made for Serilog. Okay, here I'm committing all the changes. I didn't record some of these changes. If you like, you can check it out by looking at the commits. So in this section, I want to configure our front end so that it automatically displays a general error page whenever we get a 500 error. The log middleware that we made in the API project is going to return an internal server error if any error or exception occurs. Now, it's a good idea to redirect the user to a nice error page in this situation. This is the general error page we will show. Of course, I prepared it in 2 languages. Also, the About Us page. And the home page that we saw together before. Okay, let me show you the error page code. Well, there's not much code in it. What this does is simple. It checks the current culture. If it's Dutch, it loads the Dutch version of the component. Otherwise, it loads the English one. This way, you can create separate components for each language and fully customize the content without relying on resource keys for large texts. And of course, you can easily extend this to support more languages if needed. So far, we've been using culture key value pairs like resource files for small texts, such as a word or a sentence. That's great for labels, buttons, or short messages. But if you have a page with a lot of content, like full paragraphs or articles, translating all that with resource keys can get messy real fast. I've placed the page components in this folder. I've done the same for the About and Home pages. Now, let's jump into showing that general error page when a 500 error happens. For this, we're going to head over to our authenticated HTTP client service. Here, I'm going to add a super simple condition to check if the API response is an internal server error, that 500 error. If it is, we're going to redirect the application to our error page. That is pretty simple, isn't it? Okay, so this works functionally, but it has a little problem. We're using Navigation Manager inside a lower-level service method. While this technically works, it's generally not the best practice. This method is responsible for sending HTTP requests and managing authentication, not controlling page navigation. It tightly couples our service logic to the UI navigation layer, making it much harder to test, reuse, or maintain. When navigation logic is inside a method like this, unit testing also becomes more complex, since navigation is really a UI concern. So because of that, I want to move all the navigation from this class to our error handling class, and our HTTP service stays clean and focused. So here's what we're doing instead. We'll create 3 methods inside error handling service in order to refactor our HTTP client service. Navigation Manager should inject to the class. and I'm going to paste these methods here. They are simple but make our architecture cleaner, more testable, and much easier to maintain as the app grows. As we are here, let me update these error messages. They are related to the refresh token method in the service layer I've forgotten to add here. It looks fine. Alright, let's go ahead and refactor authenticated HTTP service. Now here, instead of calling navigate2 from Navigation Manager directly inside this class, we simply call redirect to error page from Error Handling service. This way, our service just reports the problem and delegates the decision of what to do next. Now I'm going to remove Navigation Manager. It is not needed to be injected to the class anymore. And here, instead of redirect to login page, simply I call handle unauthorized. Here I missed else after if block. I'll do the same for the delete method. And this one isn't necessary. Here, I'm going to call another method from error handling to ensure the result is successful, or to handle the error. Also here. And here. In the catch section, we don't need to send the user to the login page. Instead, we navigate the user to the error page and return an internal server error. If you want to test this try-catch, I'm going to put an exception here, then you can uncomment it to test and debug the method. Now, as the last step of the logging section, I need to set the user email in order to add the current user's email into the log. To do that, in the login method after the user is logged in, I'm going to set the current user email from logs enricher to the user's email. Another scenario is maybe the user already has logged in and has a token. In this case, I have to set the user email after the app starts. The best place for this is the main layout page, where we load the token from local storage. I'm going to add another method to the token store class to get the email from the token. And now here, I'm going to call it to set the user email. Alright, the logging section is done. In this section, we're going to dive into something super important for building robust and reliable applications: automated testing. We've been working on our CRM project, and now it's time to make sure our code is doing exactly what we expect it to, and that we can make changes confidently in the future. The first step is to set up our testing environment. The best practice in .NET is to keep your tests separate from your main application code. It keeps things clean and organized, so we're going to create a new project in our solution specifically for our tests. Now, in the Add a New Project dialog, I'm going to search for Test in the search bar. As you can see, we have a few options pop up. These are the main testing frameworks in the .NET world. For now, we'll focus our initial testing efforts on the service layer of our application. This is where our core business logic lives, and testing this layer thoroughly gives us a lot of confidence in the application's behavior. In the future, I will try to add more tests to the project, but for today, our main focus is on the service layer. For this project, I'm going to choose the XUnit test project template. Why XUnit? Well, there are a few reasons why it's become a really popular choice in the .NET Core ecosystem, and often the recommended one, especially by Microsoft. First, it's very modern and streamlined. It was built from the ground up to take advantage of .NET Core's features. Second, it has a slightly different philosophy compared to in-unit or MS test. XUnit encourages cleaner, more focused tests by, for example, not requiring a test class attribute on your test files and using fact and theory attributes, which can lead to better structured and more readable tests. It's also generally considered to be quite performant and integrates really well with Visual Studio's Test Explorer. While Unit and MS Test are absolutely valid and powerful frameworks, you might even prefer them based on past experience for new .NET Core projects and for the kind of straightforward focused unit tests we'll be writing for our service layer. XUnit is an excellent and common choice. It's simple to get started with and really helps enforce good testing habits. Since we're going to be testing our service project, I'm going to name this crm.service.unittests. This naming convention clearly tells us what project it's testing and what type of tests it contains. And there we go, our service.unittest project is now added to our solution. Now let's pick one of our services to write some tests for. Okay, first up, I'm going to choose the user service. Now I'm going to ask Copilot to help me out here. Let me just make this a bit bigger so it's easier to see. First, I'm going to ask Copilot to list all the probable tests for this class. As you can see, it gave us a pretty good answer. Now, I'm going to create the test first, and then I'll ask Copilot to complete it. For this, I'm going to use the same structure I have in my service, the same folder structure. So I'll create the identity folder first, and inside that, I'll put user service tests. This one can also be deleted. Now I'm going to ask Copilot to complete the class based on all the suggestions it gave us in the previous message. Pay attention to this checkbox right here. If your question for Copilot needs it to consider another file or files, make sure those files are open, and this checkbox is ticked, just like I have the user service class open right now. You might know better ways to interact with Copilot, and that's totally fine. This isn't a fixed rule. Everyone has their own method. I'm just trying to give you a general overview so you can start using it for certain tasks, which, by the way, is incredibly useful. For example, in this case, we could ask Copilot to create the file for us too, or even at the very beginning, ask it to write all the tests. It really depends on how you prefer to interact with it. Okay, the test is ready. I can copy it with this button and paste it into the relevant file. Alright, there are lots of errors here, but we can fix them. Here, by placing the cursor and pressing Ctrl and dot on the keyboard, this suggestion list pops up. And here, I need to reference the models project. Also, I need to install the MOQ package. Okay, I also need to add a reference to the service. All the errors are fixed, except for one that's still here. This one also needs its appropriate using statement. Excellent. All the errors are gone, but we still have a few warnings. To fix those, we can use another feature of Copilot. I'll place the cursor here, and press Alt+/ to open this inline chat box. And here, I'll ask it to fix all the warnings. Well, as you can see, it shows its suggestions like this, just like files that have changes in Git Changes window. This way you can see the before and after changes. Okay, I agree with these changes, and I'll hit the Accept button to apply them. Now, no more warnings, no more errors. Okay, I'm not gonna dive deep into this test class to explain every detail, because this video would get way too long. If you think it's necessary to spend more time on tests, please let me know in the comments, and I'll create a separate or follow-up video for it. However, given that we develop the service together step by step, I think the tests should be easy to understand. You can debug the test to examine their execution flow. You can also ask Copilot itself for help in explaining any unfamiliar parts. Okay, let's run the tests and see the result. For this, I'll open the Test Explorer from the Test menu. Well, as you can see, all the tests are listed here. We can run them with this button. This might take a little while because the project needs to build, and then the tests will run one after another. Fantastic. All the tests passed successfully. I'll create the tests for the authentication service later and commit them for you so you'll have access to the code. I won't record that in today's video because the process is exactly similar to what you just watched. Alright, we've reached the end of this episode. I really hope it was useful for you. In the next part, we're going to implement the unit of work and repository pattern, and our main focus will be on the data access project. We'll probably add a few entities to the project, and by including tenant ID in some tables, we'll try to implement multi-tenancy and get the project to support multiple tenants. Please share your comments and suggestions with me. I'd be really happy to hear them, and they can definitely help make this tutorial series even better. Take care, and I'll see you in the next video. Happy coding!